All right, guys, law of sines, or law of cosines today, because we've already completed law of sines. We do law of cosines when we're given side, angle, side, or side, side, side. The general idea is this formula right here. And if we just remember that the letters on the outside have to match, then it's a little easier to memorize. If we are in class, I make you memorize that. You also have an alternate form, which is over here. And all that means is, what would I do to get cosine A by itself? Well, I would subtract B squared, I would subtract C squared, and then I would divide by negative 2BC. And to make that look prettier, I would get this right here. All right. So techniques, if we are wanting to use, if we're wanting to solve the whole triangle, so angles and sides, we always want to find the angle opposite the longest side first. That allows us to use law of cosines for, or law of sines for all the other things. So we'll see that in action. And then for side, angle, side, you want to find the side opposite the given angle. So let's look at both of those. So the formula here for the alternate angle, I'm going to change this color up a little bit, is cosine A, and we're actually going to do C, because if I look here, I have a triangle that A is 13, B is 7, and C is 19. So that means that C is the longest side, meaning that's what I'm going to solve for first. Okay. So cosine C will equal 13 squared plus 7 squared minus 19 squared all over 2 times 13 times 7. Now, you can get a number there and then do the cosine inverse. What I like to do is type it all in. My calculators are real smart now. So I just like to type it all in one time. If there are some things you can simplify first, please do. That's totally cool. Remember, you do need to be in degrees, so you want to do Desmos Scientific so that you can see the degrees. And to save a few seconds on this video, I've already typed that in, and I get approximately 141.786 degrees. I can obviously round that to 142. So just like before, I really probably should have started this with my setup that I always do for A, B, and C. Here's why this is helpful. Next class, we're going to look at doing, like, I'm just going to say, here's a triangle, solve it. And you have to decide whether to use law of sines or law of cosines. So if you fill this in first, you see, hey, I don't have any letters the same. So like I don't have A and A, B and B, C and C. So therefore I know I have to use law of cosine. Okay. So that's why I always recommend putting that box first. We found that C is 142 degrees. Since we found the longest side, we can now switch to law of sines if we want. So if you wanted to go through and use this formula every time, you're welcome to. That's fine. I think that law of sines is a little easier. So I could do sine of 142 over 19 is equal to sine of A over 13. Cross multiply. And divide. And then do sine inverse. Hopefully you have done enough of those problems to be able to do that. If not, go ahead and write those problems out to get to that point. And when I type that in my calculator, I get approximately 24.91 degrees. So we'll say 25 degrees. Well, now life is easy so this was step 1, this was step 2. Step 3, we're just going to do 180 minus 142 minus 25, and that's going to leave us with 13 degrees. Okay. Same idea here, except now I have 2 sides in the included angle. So this is really, like side's pretty easy to remember. Hey, I need to use cosine. But sometimes if I'm given this information, I don't remember. So if I do 102 degrees, 5 and 3, I notice that I have no A's together, no B's together, no C's together. So I must use law of cosine. And since I have big A, I'm going to find little a. And so the formula from the top looks like this. So to undo a squared, I would square root. B squared would be 5 squared. 3 squared minus 2 times 5 times 3. Cosine of 102 degrees. Again, I'm going to use Desmos Scientific. I'm going to type that entire thing in my calculator, and I'm going to get approximately 6.34 for A. Well, once I have that, I can use law of sines to figure out B or C. Okay, it doesn't matter. You can do whichever one. So if I do, let's say I find C, I can do sine C over 3 equals sine 102 over 6.34. Cross multiply, divide, whoops, that should be a 4, and sine inverse. I'm running out of room there. And I'm going to get that C is approximately 27.57. Okay, so approximately 28 degrees. So for B, B is going to be the easiest. 180 minus 102 minus 28. It's going to leave me with approximately, or actually that one's going to be equal, not approximately, 50 degrees. So law of cosine is pretty easy. The last part that I want to stick in here, there are applications. If we were in class, we would totally do more of those. Feel free to challenge yourself with those. But in our virtual setting here, we will keep on going. There's also an area formula. So this is for area, just like our other area formula for an oblique triangle. It doesn't have a great name. This one does have a great name, Heron's formula. And I'm sure that comes from some mathematician with the last name Heron. But again, you can Google search that. And so if we're just given the 3 sides, we can still find the area. What we need to do first is find something called S. And we find S by doing 1/2 of all the sides added together. Okay. So type that in my calculator to get 20.5. Or you can add 7, 16, and 18 together to get 41. Half of that is 20.5. And then to find the area, I use S and I subtract each of the sides from S, multiply those together, and multiply it by S. So I'm just copying this formula right here, subbing in S and all my sides. From there, yeah, you can simplify. You can figure out that 20.5 minus 7 is 13.5. You can figure out that 20.5 minus 16 is 4.5. That's not really necessary because, again, we have super smart calculators. So I would just start with the square root, type it all the way to the end, and I would get that the area is approximately 55.80 meters squared. And that's all there is to the area formula. And that concludes law of cosine.